Hello students, welcome to Saraswat classes. This is Dr. Sarkar over here. In continuation with the topic of protection and deprotection of functional groups, we will be discussing today the protection of alcohols, and there are very many processes in this. So we will be discussing them one by one. So we can do this via using a benzyl ether, protective group such as CH2PH or designated as BN. The advantage part of using CH2PH is it is very stable to most reaction conditions and can be removed by catalytic hydrogenation, which is by the use of H2PD. So let us take an example and see how this is used. Suppose we have this secondary alcohol isopropanol, okay, and we are using PHCH2Br, also can be designated as BNBr, in presence of base to take up the HBr that will be released in the reaction medium. So it will lead to the formation of this ether, also can be called or represented as in this way. Now, how to deprotect the ether and regenerate the alcohol? So simply adding H2PD will reduce to remove the BN protecting group. Similarly, one may also use the p-methoxy benzyl ether, can be represented as CH2 C6H4 OCH3, or can be abbreviated as PMB or MPM when we call it as methoxy phenyl methyl. So there are two ways of calling this protecting group. So it is very easily to simply put on and can be removed by oxidation of the benzylic position, which is this one. So for deprotecting, we will use 2,3 dichloro 5,6 dicyano benzoquinone, or also known as DDQ. So let us demonstrate this reaction using line diagrams in which our protecting group is as shown. This is the structure of the protecting group. Again, we will use the base for similar reasons. So this is basically adding of PMB, the protecting group, and that obviously leads to the formation of this type of an ether. Also can be represented as something like this. Now, while deprotecting, as we have mentioned in the theory, the reagent to be used obviously is DDQ, okay, which will oxidize, as I have said, the benzylic carbon and regenerate the alcohol after the reactions taken place. Another way of protecting an alcohol will be by using triphenyl methyl or also known as trityl, that is basically CPH3 or also abbreviated as TR, and this can be cleaved with the use of a acid because the trityl carbocation is highly stable via resonance, and so one can say that PH whole thrice CCl. Again, we use the base, reasons have been explained before, or we can call this as TRCl. Okay, so this is basically adding of the TRCl to the alcohol, which will lead to a molecule of this kind, which can also be called as or represented in the following manner. Now, when we are to think about deprotection, what do? We simply treat this with the acidified water, and so over here hydrolysis will take place and remove the TR protecting group. Another way of protecting alcohols will be via using silyl ethers. So what do we do in that case? Okay, suppose again we take this alcohol and over here we are using Si joined to 3 Me groups and 1 chlorine, also known as TMSCl. We also use catalytic amounts of base to take up the HCl, which is formed as the byproduct of this reaction. So this is basically adding of TMS, the protecting group, which will obviously lead to the formation of a silyl ether, also can be represented as follows wherein we are using the abbreviation TMS. And if we were to remove this TMS, then one has to employ deprotecting reagents as tetraalkyl, or over here as we can see it is tetrabutyl ammonium fluoride. Fluoride has a high affinity for silicon, and so it will cleave by making a nucleophilic attack to the silicon, and this particular bond will be cleaved. Okay, and that will be the process of deprotecting silyl ethers and regenerating the alcohols. This is also known as TBAF, which means tetrabutyl ammonium fluoride. Thanks for listening. Keep visiting Saurabh classes for further lectures on protection and deprotection of organic molecules. Have a great day.